All right, so I'm here with Carly, and we're doing part G now, which is um, going to be, I'll write this out, y equals natural log of 2x plus 1 over x minus 1. All right, so what's our plan for something like this?
Um, can we start with the chain rule?
So we actually have a couple strategies, and we could apply the chain rule to this,
It looks
but
like quotient, though, like in the parentheses looks like quotient.
yes, in the parentheses right now it's a quotient. And the quotient can be a little bit involved. If you remember, it was the low D
Yeah.
high minus the high D low, or in other
Yeah.
words, it's the so if we make this F and we make this G, then it would be bottom times the derivative of the top minus top times the derivative of the bottom divided by the bottom squared. So we could apply the quotient rule to this. However, with logarithms, we actually have a fancy little algebraic trick that we can do to separate this out and handle it more easily.
Okay.
So what we could do, and this is what I would recommend, is to separate this out into, so with logarithms, so let's say we have the natural log of m divided by n. One of the
Uh-huh.
rules of logarithms is that I can separate this out and call this the natural log of m minus the natural log of n. So in other words, I can put a minus sign in between them, give them each their own natural log, and separate those uh, uh, values, the numerator and the denominator. So this would be natural log of, so in this case, it's as if this is the
Oh,
m
natural.
and this is the n, right?
Right. So natural log of 2x plus 1. 2x plus 1. Um, Minus natural log of x minus 1.
Good. And since we can take the derivative of these natural logs individually, like each term we're gonna handle separately.
Okay.
That lets us find the y prime by taking the derivative of this and taking the derivative of this separately. Do you remember when you take a natural log, how that works? What's the
Um,
derivative?
I have it written.
Okay.
Um, ln, well, ln of something equals 1 over that something.
So it's one if it's a, well, you'll see. It's actually the derivative of this. So
Okay.
if it was an x on the top, then it would be one, but this is going to be a two in this case.
Okay.
So the derivative of 2x plus 1 is just the 2 divided by
Right.
the original 2x plus 1.
Okay.
And then it's going to be a minus, and then we're going to have the derivative of x minus 1, which is
1.
1. And
Okay.
then divided by the
X minus 1.
x minus one. Mhm.
Okay. Um, so now I want to get like common denominators, right? So that I can, or can I bring the stuff up onto the top and, like change the sign?
Common denominators are good.
Okay.
I would say let's go ahead and try that approach. So
So we need a 2x plus, so this second one, the 1 over x minus 1, we're multiplying by 2x plus 1, top and bottom.
right. Each one gets the other.
Okay. And then the 2 is being multiplied by x minus 1, and bottom 2x plus 1 multiplied by x minus 1. Okay. Now, that is going to do y prime equals 2x minus 2 over 2x squared.
We don't
Wait.
necessarily have to multiply that out. We can leave it
Oh, we
factored.
don't?
No, we'll just go ahead and leave that factored.
Okay.
But they will now both be the same.
Okay.
So
Then
we
we
can write
have
that at once.
minus 2x. Is that minus 1 times plus 1?
That's right. It's going to
So
be
minus 1.
-1.
Minus 1.
All right. And it looks like I've got a 2x here and I've got a minus
Oh, and I
2x here.
don't, wait.
That's
Do I have to do,
convenient.
is it minus 2x minus 1? Oh, yeah, I see that. Okay,
Yep.
minus
hmm
2x minus 1. Okay. 2x's cancel. So then I have y prime equals -3.
Oops. I keep using highlighter. Okay. So
Y prime
-3.
over 2x plus 1, x minus 1.
Okay.
Now,
Looks good to me.
because that can't be simplified anymore.
No, I think that's about as far as we're going to get with it.
Okay. Beautiful. Now we only have one more.
hmm
Okay, but I think this last one is going to be a process. Just
So
because
let's
he's
see
left so much
here.
space at the bottom makes
Right.
me believe that there's a whole page.
All right.
Which scares me.
So it says find all x values where the derivative is undefined or where the derivative is 0. Note, in class, we called these the critical points. So we have to find the critical points for f of x equals x squared over 2x minus 1.
Mhm.
All right. So to find all the places that it could equal 0, or where the derivative is equal to 0, we can all x values where the derivative is undefined or where the derivative is 0. So where it would be undefined would be wherever the denominator is equal to 0.
Okay.
So we can set this equal to 0.
So then we get 2x equals 1.
And then we can divide those by 2.
Right. So we get x equals 1/2.
Mm-hmm.
So when x equals 1/2, the denominator is 0.
That's right. And the derivative, remember that if we took the derivative of this, we've got our u and our v, if we are looking at it as the top and the bottom. And the bottom squared is going to be what we get with the quotient rule. So that would be on the denominator of the derivative, not just the original equation. So
So,
that is an undefined. So that is one of the critical values.
okay. Is that it? Or we have to do more?
Well, that's one of them. But also anywhere that this overall derivative is equal to 0, we have to set it equal to 0 and solve for that too. So let's take the
Okay.
derivative of the entire thing. And that would require the quotient rule, right? So it's going to be the bottom times the derivative of the top. And what's the derivative of x squared?
Oh, wait, 2x minus 1. We said it was 1.
Not 1.
Oh, wait,
It is x to the first power, but it's the
which is
derivative
0.
isn't 1. It's x to the 0, and x to the 0 is
1
1.
uh,
So 2 times 1 is what we get there.
is
So
okay, 2.
there should actually be a 2. Um, Did I lose track of that? We're actually doing the derivative. We're doing the original of the bottom times the derivative of the top. That's supposed to be 2x because the 2 comes down in front and then we subtract 1.
Oh, yeah.
So that's for the derivative of the top, or u prime we'll call it. And then we have minus the top
Which is x squared.
times the derivative of the bottom.
Which is 2. Oh. Wait, derivative of the bottom. Isn't the derivative?
The derivative is 2. Sorry about that. You're right.
Okay.
Good catch. And then that is divided by the bottom squared.
2x minus 1 squared. Okay. Can
So let's simplify that. I'm going to scoot
we
this down a
cancel
little
out
further.
a 2x minus 1?
Well,
And then just
we
have it be 2x minus x squared?
so what you're imagining is we've got this and we've got this. Why don't we just cancel those out,
Yeah.
right? The problem is that we have a minus sign and there's this other third term. And cancel that, if we cancel that from the first two, that would be sort of like doing this. What if we had a 4 minus 7 divided by a 4? We can't just cancel those out.
Oh. Oh, because it's attached to something.
Right.
Okay.
It's all that's all um in an invisible set of parentheses. So this is one of the things that kind of trips people up because we never
Yeah.
show them, but that entire numerator and that entire denominator are inside of parentheses if you
Oh,
want to
okay.
visualize it that way. So we've got to handle this within its own self. So we could distribute the 2x to each of these.
Okay.
And then that would give us 4x squared minus 2x minus 2x squared.
You're gonna make me start yawning again.
Sorry.
It's okay.
All divided by 2x
Minus.
minus 1 squared.
Can we combine the 4x squared and the negative 2x squared? Okay.
Absolutely. Let's go ahead and
So
do
we
that.
get
So
f prime of x equals 2x squared minus 2x over 2x squared. No,
2x, let's leave it as
2x.
2x minus 1 squared. Yeah.
Okay.
And then
Minus
we're going to set this equal to 0.
the whole thing.
Mm-hmm. So if this is going to be equal to 0, then what that means is that this numerator right here, well, we can multiply both sides by the denominator, 2x minus 1 squared. We can multiply it by that denominator, and then that's going to make it cancel out, right? So if both sides, because 0 times anything is 0.
Oh, okay.
So you could kind of think of it like this and cross multiply if you want to look at it that way too. It's another way
Okay.
to see it. So that's going to give us 2x squared minus 2x is equal to 0. And I can simplify this a little bit. What could I do to simplify?
Um, divide by 2.
I could divide by 2.
Is that what you were thinking?
That does work, but that it doesn't finish it though. We still need to do more.
Mm, I don't know.
So when you have, let's say x plus 3 equals 14, something like this, your goal is to try to get x by itself. So you're going to subtract over and you're going to try to get x all by itself. And that's our plan for those situations. But in a case like this, where we've got x squared, if we have x squared, then what we want to do is have it just like it appears here, but turn it into, factor out the x and turn it into this. So we do want to keep it as squared, but we'll factor that out so that it's two linear terms multiplied together.
Okay.
And the reason for doing this is because now we can set each one individually equal to
Oh.
0.
So x, when x equals 1.
So x equals 0 and x equals 1.
And x equals a half.
And x, so those are all critical values, yes. X equals negative a half is where it's undefined. So we know
Oh,
we're
is
not
it
going to get an
negative
x.
half?
No, it was, I'm sorry, I
Okay.
misspoke. I misspoke. That was supposed to be
Okay.
positive one half, right? Yeah,
Yeah.
yeah. Critical value is one half.
So
But
that's our
but
answer.
so that is going to be where it's undefined, where we have an asymptote, and then these other locations are where there's points. But
Oh, okay.
but those are also where the derivative is equal to 0. So those
So it's
are
undefined at
one half.
1/2. Okay. And the other one is just the critical points.
Mhm.
Okay. So it's undefined at x equals 1/2, and my critical points are x equals 1 and x equals 0.
Mhm.
Is that it?
Right. Yes. Those are the critical values.
I'm done. I can go to bed.
Well, almost. I'm just going to
Oh,
elaborate on what those critical values mean. So
oh,
we have 0 and we have 1 and then we have 1/2. And this is where it's undefined because there's when we put 1/2 in there, we get 0 in the denominator and you can't divide by 0.
no.
And these places at 0 and 1, what that means is that those are places where and I don't know exactly what this looks like. We could throw it in the graphing calculator and maybe it looks something like this. So it could look like, I don't know. I'm just going to
But it'll be a
hypothetically say,
parabola.
yeah, let's say hypothetically that it looks like this.
Okay.
And then, so what that means is that right here, the tangent line is 0. That's when we solved and we got 0.
Oh,
That's what those mean.
okay. That makes sense.
And what makes them critical values is that they can switch from being decreasing to being increasing at those critical
Oh,
values. And then
okay.
here it switches from being increasing to being decreasing. And critical values are where that is possible to happen.
Oh, okay. That makes sense.
And now you can go to bed.
I have to clean my apartment first.
Fair enough. Fair enough. But good job. That's yeah, I think that's as far as we need to get with this stuff. So I'm gonna
Okay.
stop record.